Hey guys, today we'll start with a quick review of SOHCAHTOA. Remember that sine of theta is opposite over hypotenuse. And the reciprocal cosecant of theta is hypotenuse over opposite. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. The reciprocal of cosine is secant. I forgot my theta here. And that would be hypotenuse over adjacent, and cotangent of theta is adjacent over opposite, because cotangent is the reciprocal of tangent. Now these are all, we've already gone over these. I think you guys felt pretty good about these. I just want to do one practice problem just to refresh your memory. If we have a triangle ABC, and this length is 1, and this length is square root of 17, and we don't know this length. In order to find this length of the triangle, we'll have to use Pythagorean theorem. Remember, that's a squared plus b squared equals c squared, where c squared, or c is the hypotenuse. So 1 squared plus, you can just say x squared, or you could say b squared if you wanted to see it here, is equal to c squared, and here c is the square root of 17. 1 squared is 1, and the square root of anything squared is itself. So the square root of 17 squared is just 17. Subtract 1 from both sides, and we get b squared equals 16, so b equals 4. So now we could find some information. For example, if we wanted to find the sine of angle A from A, we would say, remember, it's SOHCAHTOA, where so, I'll write it down here so you guys can see it. SOHCAHTOA. The so means opposite over hypotenuse. So from angle A, the opposite is 1, and the hypotenuse is the square root of 17. We can't have a radical in the denominator, so we have to rationalize the denominator. To do that, we multiply the numerator and denominator by the radical in the denominator, and that gives us the square root of 17 over 17. So sine of A is square root of 17 over 17. Next, let's say we wanted to find the tangent of B. So from B, tangent's TOA, opposite over adjacent. So opposite of B would be 4, and adjacent to B would be 1. So the tangent of B is just 4. If we wanted to do a reciprocal, for example, if we wanted to do the secant of A, so secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. So secant of A is hypotenuse over adjacent. So that's square root of 17 over 4. If we wanted to do the cosecant of A, remember, cosecant is the reciprocal of sine. And since sine is O over H, then the cosecant is H over O. So in this case, that would be from A, the hypotenuse, which is the square root of 17, divided by the opposite side, which is 1, or just the square root of 17. So if we wanted to do the cosine of B, from B, cosine is A over H. So the adjacent side is 1, and the hypotenuse is the square root of 17. And then we can't have a radical in our denominator, so we'd multiply the numerator and denominator by the radical in the denominator, which would give us the square root of 17 over 17 as the cosine of b. Let's say we want to do the cotangent of a. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. From angle A, the adjacent side is 4, and the opposite side is 1. So y'all can just review intro to trig. I can give you guys a practice problem to work on. Let's do... I want y'all to do this problem. This is A, this is B, and this side is C. And you can do, let's do the square root of, let's do the square root of 11, and let's say this side is 3, okay? Actually, I'm going to give you guys a one that's doesn't involve radicals. You do need to know how to rationalize the denominator. Let's do this one. This one actually does have a radical in it. Let's do 5 square roots of 3, and this side can be 5. Okay, I just want you to practice finding all 6 functions. I guess that would end up being 12 because I want you to do the sine, cosine, tangent, cosecant, secant, and cotangent for angle A and for C. So you'll do sine, I can write it sine of A, sine of C, cosine of A, cosine of C, tangent of A, tangent of C, and then I also want you to find the cosecant of A, the cosecant of C, the secant of A, the secant of C, and the cotangent of A as well as the cotangent of C. And you can practice more of your reference angles as well.